Hello and welcome to my YouTube channel. This is Dramani Julius and this is Dramani Online Mathematics. Today we are looking at how to differentiate an exponential function. If you look at my previous lesson, we have already looked at exponential functions. And let's say if I have a to the power x. This is an exponential function because we have a base and what? Exponents. And this base must be in the integer form. Or a rational number. Alright, so we're looking at this. Then we can say that 2 to the power x is what? An exponential function. 3 to the power 2x plus 4 is an exponential function. But 3 to the power 4 will give you 81, so this one is not what an exponential function. So we have to get a number to the power a variable. That will give us an exponential function. So now let's look at how to differentiate this. So if I have a to the power x and I'm asked to find dy dx, meaning that I'm going to differentiate with respect to what? X. Let's say y is equals to that. Then my dy dx will give me this. Now let's look at how we go about this one. First, we maintain the whole function. So the function here is a to the power x, then you multiply by the derivative of the power times length of the base. So looking at this, our dy dx will give differential of x will be what? 1. So that will give you a to the power x multiplied by length a. So that's how we differentiate exponential function. So example, find dy dx of y equals e to the power 3x squared plus 4. So now let's look at how you can solve this example. So we said that first thing, our dy dx is equals to, first you are going to maintain the whole function, which is e to the power 3x squared plus 4 times the differential of the power, which is 3x squared plus 4 times length of the base. From here, our dy dx will be e to the power 3x squared plus 4 times, if we differentiate this with respect to x, to give you 6x, but this one will go to 0, times, take note that length e is 1. So whenever I see length e is always 1. So from this side, we have our dy dx to be equals to 6x e to the power 3x squared plus 4. Someone can also decide to go in different way or differentiate this one in different way by using the chain rule. Now if I want to use the chain rule to differentiate this, I have y to be equals to e to the power 3x squared plus 4. The first thing to do is let's u to be equals to the power, which is 3x squared plus 4. Now we differentiate this one. Now this u becomes the dependent and the x is independent. So to be the u dx, and that will give you 6x. Alright, so let's move with this one. Now we are saying that y is equals to e, but the whole of 3x squared plus 4 is now u. So I'll replace here by u. In this case, our u here become the independent and the y become what? Dependent. So this side will give you dy du, which will give you the same thing, because we are saying that you maintain the function times the differential of the power multiplied by ln of the base. So e to the power u times, you are differentiating with respect to u, so that will give you 1 times ln of e. I've already said that it is 1, so this will give you e to the power u. Now after getting this, you substitute the value of what? U into this. But before you do that, let's look at something here. The question asks us to find dy dx. And now we have this and that. So let's multiply them. dy du multiplied by du dx. So you can see that this du and this du cancel. When it cancels, it will leave with dy over dx, which is the same as that. That's how the chain rule works. So now I have dy dx is equals to dy du is e to the power u multiplying du dx, which is 6x. So dy dx will be 6x e. Now our u is 3x squared plus 4. Very good. So you can easily do this by using the chain rule, or you go straight to solve that. Now let's look at another example. Next example. Y equals 5 to the power 3x squared plus 2x plus 1. Find dy dx. So you want to differentiate this. First, I'm going with the straight way method. So I have my dy dx because I maintain the whole function, which is 5 to the power 3x squared plus 2x plus 1. So I've maintained the whole function. multiplying by d dx of 3x squared plus 2x plus 1 times length of the base. So dy dx will now give you, if you differentiate this will give you 6x plus 2. So 6x plus 2 multiplying 5 to the power 3x squared plus 2x plus 1 times length 5. So this will give us our answer. Now let's also use the chain rule to do it. For the chain rule, then write the question 5, 3 to the power 3x squared plus 2x plus 1. So the chain rule, first thing that I have to do is I have to let u to be equal to 3x squared plus 2x plus 1. Then differentiate the u with respect to what x, and that will give you 6x plus 2. It means that our y is now 5 to the power u. So we're going to differentiate the y with respect to what? U. And this will give me the function times the differential with respect to u of the power times length of the base. So this is giving me, if you differentiate u with respect to u, you get 1. 1 times that will give you 5u. So you have 5 to the power u multiplied by length 5. So now, once this one is changed, we have to get this way. Dy dx is equals to du dx multiplied by dy du. Now you can see that the du and the du will cancel to leave with dy over dx, which is here. So now let's continue. So our dy dx, du dx, we have 6x plus 2 multiplying dy du. Our dy du is this, which is our dy du is 5 u length 5. So dy dx will be 6x plus 2 5, but our u is equal to, that's 3x squared plus 2x plus 1 times length of the base. Very good. So this is how we differentiate exponential function. Now let's also look at how to differentiate logarithmic functions. Let me pause.